Okay, so and beta is going to be minus 1 by R dash. Beta is inversely proportional to the feedback resistance R dash. And the basic amplifier, you can draw the AC equivalent by grounding the voltage source, and you can see this R dash will be coming in parallel on both sides. You can see that in the simplified diagram, the see here. So since the input side is going to be having current, is going to be same in the parallel connection. Also, so we will be having in the input side, I'll be having the current source. In the output side, I'll be measuring the voltage. Okay, the input side in shunt, you will see what is getting added. So in shunt, current will be getting added. So in the last case, we have seen current series where the input side was series. In series, voltage gets added. Okay, so we have to be very clear on what is measured at the output and what is measured at the input, and accordingly that circuit should be used in the AC equivalent and hybrid equivalent model. So in the voltage shunt feedback amplifier, the shunt term is coming in the input side. So current is going to be additive in shunt. So I'm going to use current source at the input side. The current source will have parallel resistance RS. You have this resistance R dash also. So I'm considering the parallel combination to be capital R. The output side, I will have R dash again parallel to RC. That will also be coming. Okay. And beta is going to be IF by V naught. So it is minus 1 by R dash. So first we will find what is RM. RM is going to be V naught by II, or it is V naught by IS. And what is V naught? It is minus IC into RC dash. And RC dash, there is parallel combination of RC and R dash. So minus IC into RC dash by IS. And IC, it is minus HFE into IB divided by IS. And here in the input side, total current is IS, and you have a shunt term. You have a shunt term, and you have the current IB flowing through the base. So you have to apply current division. So IB equal to total current into opposite. Opposite is R divided by opposite plus that resistance. It is flowing through HIE. So IB by IS equal to R by R plus HIE. And I'm assuming R to be, this parallel combination is going to be RS parallel to R dash. So it is RS into R dash by RS plus R dash. So substitute this expression for IB here, and IS will get cancelled. So RM is going to be minus HFE into RC dash R divided by R plus HIE. So this is the expression for trans resistance RM. So immediately after finding RM, you will be finding plus D. D is going to be 1 plus beta into RM. So substitute and have the fraction ready for capital D. And with feedback, it is given by RMF equal to RM by D. So divide the expression for RM and D. You will get this expression RMF equal to RM by D. So you will get this answer. And you can also write what is the voltage gain AVF equal to V naught by Vs. V naught is V naught by Vs is Is into Rs, and V naught by Rs, V naught by Is, it is going to be RMF. So AVF equal to RMF by Rs. And what is RMF by Rs? RMF, you have found the expression, this term, and Rs is going to be the source resistance. The current source parallelly, you have a resistance that is going to be your RS. And input resistance, what is RI? See the input resistance, RS, R dash, HIE, all are in parallel. So I can write RS parallel to R dash parallel to HIE. RS parallel to R dash, it is, so it is R parallel to HIE. In voltage shunt feedback, RIF will be lesser in value. RIF equal to RI by D. So it is R parallel to HIE divided by D. And same way in voltage shunt, for voltage shunt, output side, if you see, R naught will be equal to R dash, and R dash is going to be this resistance, and R naught F is going to be R naught by 1 plus beta RF. For voltage shunt amplifier, the input resistance will decrease with feedback, the output resistance will also decrease with feedback. Both will be decreasing. So the different R naught dash also you can find. So R naught dash is going to be R naught F dash is going to be R naught dash by D, or straight away you have a formula R naught F dash equal to R naught F parallel to RL. So whatever method you are going to find, see here the other last formula is given R naught F dash equal to R naught F parallel to RL, or it is also you can find using the conventional formula for feedback amplifier, R naught F dash equal to R naught dash divided by D. So either you can divide and find, or you can do the parallel combination and find the expression for the output resistance of the amplifier with feedback and without feedback.